the point. But if the bid is refused, which means that there is no wind, for example, and the price of the system is very high, if the first bid is refused, all the other simulations, if I bid again, the price will be doubled, which means that I ask one time. When I ask one time, there are two effects. First, the probability that I ask another time doubles, and the price at which I ask will double also. So I can switch my behavior for some part of it, but not the total of it. And we will see later the result of this type of assumptions. Three types of sources, more easy to explain. We have a diesel engine, very big one. It's the buffer of the system. In case there is really nothing else left, the diesel engine will be there to provide electricity, of course, at a very high price. We have assumed here that the high price is 99, except for scenario 1, which we do at 50, because we'll explain later scenario 1, but we don't need a very high price. Diesel is not variable. It's always available in case there is a need for it. Wind turbines, we have assumed two very small wind turbines of 100 kilowatt. The ones which are built today have several, 10 to 20 or 30 times bigger. These are assumed to be, small wind turbines for the village, so you don't need a big one. They're offering electricity at their marginal cost. When you think about a wind turbine, how much does it cost the wind turbine to provide you electricity? Once the wind turbine is installed, it doesn't cost you a lot of money. It costs you almost nothing. So we assume that the offer price will be €1. How does the wind turbine builder then, can get back his cost? Because we will see in the simulation, but usually you have the wind turbines, but you have also other sources available, which means that the system price will be higher. So he will get the difference. Now, the wind is an input of our simulation. We do not simulate a stochastic wind behavior or something. We assume a wind that we put as an input of the system. And this will depend on the scenarios. The photovoltaic, the third type of load, small photovoltaic panel, 0.5 kilowatts. There are 150 of them. And they're bidding also at a very low price because the marginal cost of providing electricity is actually very low. And the variability, the output of the photovoltaic will depend on the sun. If there is a lot of sun, you will have a lot of power, otherwise not. Now the storage, it's actually an interesting mathematical problem to simulate and kind of optimizing the way you use your storage systems in such a power system. We have simplified the problem, and we have said, okay, there are two zones. One zone where you will consume, one zone when you will produce. Let me take an example. In function of the energy stored in your battery, let's imagine the energy stored in a battery is at a minimum level. So you have no more energy available. It means that you will be you will be happy to consume energy even if the price is very high. That's why we have a high point there. So even if the price is very high, you are happy to consume the energy. And you will produce only if the price is super high, because you have almost nothing to give. On the contrary, when the energy stored in a battery is at the maximum level, you will be happy to give it back. So even at a very low price, you will give back the energy. And if the price, since the battery is almost full, you will only consume the energy if the price is really almost for nothing. Of course, all these hypotheses can be improved in a later phase, but it's a way of doing that that for the moment gives some good results. I will give the word to Vincent to explain you more about the implementation of the auction and also the technical elements behind it.
Okay, thank you. So now Laurent has explained you all the different objects that will interact together in the simulation. So now I will explain you how they interact. So the behavior, the dynamics between the different elements. The way we have implemented the system is using a discrete event simulator that is well known in networking simulation. This is called Omnet, the version 4 Omnet. And what you see here is a screenshot of this simulator when we have loaded our different objects. So this interface is already built into the networking simulator. And why did we choose to use a network simulator to simulate a power system? This is precisely because of this convergence that is anticipated in the two networks. So we will really precisely model the interaction between the load and the sources by sending packets on on a virtual data network, so that once a protocol is available for trying, we can trying directly in our simulator. So now you are going to see how it works. There is a short video. So that's the simulator in action. We see that the red dots are in fact packets. You can inspect the packet. They are like TCP/IP packets. You can look inside. That's all built in. It's very easy. So yeah, this is a printer which is sending something. Okay, now you see in the middle the cloud is in fact the grid. There is an algorithm there that will collect all the packets. Okay, now that's it. It collects all the order, all the offer. Okay, now he runs the algorithm, and then it sends the answer back to the different load, and then the load and the sources will react according to this algorithm that Laurent has described it to you previously. So according to their state, they will decide what to do next. So in the middle of this system, there is an auction. The objective of the auction is to find a system price and then to decide who is entitled to consume, who is entitled to produce, depending on how much they want to pay. We have to say that, in fact, this auction is really central to the state at which we will reach into the system in terms of efficiency. There are many different types of auction that are discussed in the literature. This is a big subject, and we have just selected the one that we think is the easiest to try. But there are many different auctions, and they are used more and more today in different contexts. So just to cite one, there is continuous auction against non-continuous auction. We have implemented a non-continuous. That means that we do it at certain time in the day, every minute. But if you go, for instance, in your web bank account and you place an order for stock on Google, for instance, there is also an auction that will decide if you can sell or not, depending on the price. And this auction is continuous. In fact, there is somewhere an electronic exchange where this auction takes place in continuous time. But in electricity market, because in electricity market today, there is already an auction that will decide on the price, but this price is just for big company and for the wholesale market, as is it called. But for us consumer, we are not subjected to this price. So here we are just, in fact, pushing it further, pushing the system further and say, okay, if it works for big entities, why maybe it could work also for small entities. And we will show you that, in fact, it does work in terms of settling a price for every device. Then you have also different auction that says everybody gets the same price, or you get the price that you want to pay. All of these different systems could lead to a different final state, and ultimately to a system that works or doesn't work. And this is something that we can investigate with the system. But for the moment, we have just built the simpler option, a simple option, the one that is non-continuous. But it's just to say that it's also a possibility of improvement. So, as you know now, there is an auction every minute. And the auction will settle the price of electricity for the next minute. So during the minute, there is nothing to do. You can just send your offer or your bid for the minute after. But during the minute, if you can consume, you consume. There is no other thing to do. It's every minute there is an auction. You have to wait for the next one to change your state. Then, as you have seen on the video, the bids and offer, they are sent in a message. And that's very simple. You just say, okay, I want to consume 4 kilowatts and I want to pay a price of €5. Then the algorithm runs and the auction will send a message which is very similar to the message for asking for some electricity. It just says, okay, the system price is €15 and you are entitled to consume or you are not entitled to consume. And of course, we suppose that every actor in our system